Good afternoon, everyone, and welcome to today's EAStalk webinar on aquaculture in reclaimed water. This webinar is organized by the European Aquaculture Society. My name is Anna Viskovic, and I'm excited to be moderating today's session. As part of the EAS, we are committed to advancing sustainable and innovative practices in aquaculture, and this topic is particularly relevant to as we explore new ways to integrate aquaculture into circular and sustainable water systems. So why this topic matters now? Currently, there is no significant capacity in Europe for aquaponics or aquaculture with reclaimed water. But with the AWARE project, we are on the path to change that. This project aims to overcome these long-standing obstacles by integrating aquaponics with advanced wastewater treatment processes, advancing technologies for greater efficiency, and developing regulatory frameworks to help scale this approach across the continent. We are fortunate to have Dr. Fabio Ugolini with us today to share insights into the AWARE project. Dr. Ugolini is an expert in environmental sciences with extensive experience in water technology and sustainability projects. He completed his Ph.D. at Federal Institute of Technology Zurich and has since led multiple EU-funded projects on water environmental innovation. Now, as the coordinator of the AWARE project, he is driving efforts to bring reclaimed water aquaponics closer to reality in Europe. Dr. Ugolini will present on the goals and advancements of the AWARE project, after which we will open the floor to your questions. So please feel free to submit any questions you have during the presentation, and we will address as many as we can at the end. Thank you once again for joining us. Now, without further ado, I'm pleased to introduce Dr. Fabio Ugolini.
Thank you, Anna, for the nice introduction. Good afternoon, everybody. Today I will discuss about the AWARE project, put it in context of the larger thematic of aquaculture in reclaimed water. What's the state of the art in Europe? Just to start broadly to broach the topic, the project AWARE has been submitted a couple of years ago to the European Commission, supporting one strategic line that Europe has with respect to the farm to fork strategy. It might be that most of you are familiar with it. The farm to fork strategy is the strategy for Europe to increase the availability and the accessibility of food for everybody, with an eye to sustainability, better use of resources, affordability, security, and a lower environmental impact. So all the European projects that are contributing to the goal of the farm to fork strategy, they have these aspects in common, and AWARE is one of those. Specifically, AWARE has to do with aquaculture. Europe is increasingly reliant on seafood in order to provide sustainable protein to its citizens. Now, those are data from 2021. They might not be the most updated version that we have, but insofar, seafood from aquaculture and from wild catches contributes to 8% of the protein demand in Europe. And Europe wants to have more than this. Seafood production is coming from wild catches and from aquaculture system. And again, this is data from 2018, but it hasn't been changing much in the recent years. Europe is providing the vast majority of its seafood production from wild catches in a trend which is reversed compared to what is happening worldwide. If you look at the global situation in 2023, we had 90 tons of food produced by wild catches and 126 tons of food produced in aquaculture system. Global situation. In Europe, we do have a reversed trend. We have more fish that is coming from wild catches and less fish that is coming from aquaculture. Now, I come from Italy, I live in Rome. I also have the data for the Italian situation where we have a 50-50. Although we are a little bit cheating the system because most of the aquaculture production in Italy is shellfish, and the weight of the shell is computed also in these quantities. Well, overall, in any case, the bottom line is that Europe could produce more fish from aquaculture. Now, there are several barriers that makes the implementation of an aquaculture strategy a little bit cumbersome in Europe. So from technical difficulties like the control of infectious diseases or the constraints which are becoming more and more relevant from climate change, lack of diversification. Some regions in Europe, they are facing water scarcity and they don't have access to this resource. When we're talking about freshwater aquaculture, for example, we need to have new raw ingredients and new ways to make feed. And the regulation might be a barrier in the member states of the European Union. Again, to finalize the picture of the state of aquaculture in Europe, 65% of the aquaculture production comes from intensive tanks and raceway system, 33% from extensive systems like ponds and lake, and only 2% comes from recirculation systems. Now, Aware is working with an aquaponics system, with aquaponics. Aquaponics is a recirculation systems, and maybe I'm restating the obvious, is the concurrent farming of fishes with plant, where you have the plant component capturing the nutrients that result from the metabolism of the fishes and are dispersed in water. So the plants are feeding on those metabolites and clean the water, making it more suitable for the fishes to live in. Aquaponics exists prevalently as a hobby and backyard activity currently. So there's a lot of homemade systems that are used for self-production. Productive realities are still scarce in Europe, even within those 2% of recirculation systems that I mentioned before. So aquaponics has several advantages. Being a recirculation system, it saves resources because needs very little water. There's a very little water exchange with the external world. So nutrients are recycled, water is conserved. It has therefore reduced environmental impact. It can be considered multi-trophic in the sense that we are introducing a plant species in the system, although there are a multi-trophic system even within the animal species where you have a benthic component in addition to the swimming fish. So in Aware, we are connecting the circularity of the aquaponics system within the larger loop of the water cycle by introducing the aquaponics system within a wastewater treatment plant. So we want it to be part of the wastewater treatment train. This adds more benefits to this type of aquaculture if you have the system in close proximity with the wastewater treatment plant. First of all, you are more resilient to water scarcity because the water inflow is more constant throughout the year, even if you are situated in a water scarce region of the world or of Europe. We are using space within the wastewater treatment plant, which is normally not used for anything else. It cannot be used for civil purposes. It cannot be used for industrial purposes. So we are proposing a system that can become productive within the wastewater treatment plant. We can exploit the residual heat of the plant to warm the water, but actually we can also use it to cool the water, which is what we are doing in our pilot plant. And then we can exploit the residual nutrients that you might find in treated wastewater. Considering that wastewater treatment plants are also normally situated in peri-urban spaces, having fish and vegetables production within the plant can be considered part of urban farming and local production systems. So now the novelty of this project is that we want to use reclaimed water to make aquaculture, which is not an entirely new concept, although is new in Europe. The existing research, the latest papers, with the exception of a more recent review paper from 2022, comes from the group of Professor Dina Zilberg in Israel, which is on the foreground of water reuse in different applications. In these studies, they have been studying the bioaccumulation of pollutants in fish which has been farmed with reclaimed water after tertiary treatment. So the wastewater can receive 3 levels of treatment: primary, secondary, tertiary. Some wastewater received quaternary as well. Normally, you get tertiary treated water in European cities, and by farming the fishes in this kind of water, the researchers from Israel, they could see that they don't find any kind of microbial contamination. Heavy metals are below the maximum residue level. Organic micropollutants, they have similar level to the fish which is raised in natural water. So this line of research shows that it seems to be feasible to imagine having fish farmed in reclaimed water without having too many concerns about contamination. In fact, reclaimed water is already used in aquaculture across the world. If you go to China and India, especially in the poorer regions of those countries, the wastewater regulation is looser with respect of what you might expect from the European standard, and in some situation, wastewater is used just after primary or secondary treatment already as an input for aquaculture. As I mentioned, Israel has been doing it since several years, and there's already research for it. The United States and Australia, they do it throughout periods of water scarcity in the most arid regions of the country, And we had some system in Germany at the end of the 19th century in Munich, where mostly carp was wastewater fed and raised for human consumption. Now, this system in Germany, they do not exist anymore. Just a little bit more in detail of what is happening in Israel, for example. The aquaculture there is mostly carried out in cooperative farms, the kibbutz, and they need to obtain a license from the Ministry of Agriculture that also gives them leeway in using reclaimed water the moment that they can demonstrate that they have uninterrupted reclaimed water availability, that this water is free of pollutants and is free of pathogens according to the limits which are set by the Israeli Ministry of Agriculture and the Ministry of Environment as well. So if these three criteria are met, then the aquaculture receives a license and can use the reclaimed water for fish farming. I was mentioning Germany, in Munich, there were these wastewater fed ponds, which were actually part of the integrated wastewater management cycle, meaning that the ponds were also used as part of the wastewater treatment system. And in addition, the fish which was produced was useful for human consumption. Now, these systems are not operative anymore because, of course, in time, the authorities started to raise health and safety concerns. The regulation, they became stricter. Then better treatment technologies allowed for direct discharge, meaning that using fishes in the system was not seen anymore as part of the integrated wastewater treatment train, and then overall the public perception was not positive. Again, this was happening at the end of the 19th century. You have to imagine that there was much less sensibility towards thematics such as resource utilization, water scarcity, and so on and so forth. That zeitgeist was very different. We are thinking that now a solution that uses reclaimed water for farming fishes wouldn't be met with the same public skepticism that it was then, and that we can address all the other concerns as well. So the main concern now for using reclaimed water to farm fish is the actual bioaccumulation of micropollutants. The most recent study that, in addition to the Israeli one, that specifically studies micropollutants is this 2019 study. The reference is in the bottom of the slide. Suppose you're going to get the slides after this presentation. Study by Terehovs that they were farming silver perch in reclamation ponds, which were essentially artificial lakes filled with reclaimed water coming out from a wastewater treatment system, tertiary also in this case. They tracked 49 different micropollutants in the water. They were monitoring those. And those micropollutants, they belong to different classes of contaminants of emerging concerns and trace contaminants that can be found in natural water, pharmaceutical, personal care products, pesticides, industrial chemicals like heavy metals, hormones, and persistent pollutants. And out of these 49, they found out that 20 were present in the water to level which were higher than the recommended level by the Ministry of Environment. When they studied the fish, they show that despite measuring 20 micropollutants in the water, they could measure 23 micropollutants in the flesh of the fish, and this is an effect of the bioaccumulation. The fish living in the water is increasing the concentration of the micropollutants which are dissolved in the water in its flesh. And this is the part of the silver perch that gets eaten. And then they could measure 19 micropollutants in the liver, which normally doesn't get eaten, but still it's an indicator of bioaccumulation. So bioaccumulation of micropollutants in the fish is a concern when the fish is farmed in reclaimed water. So what are we doing with this project in order to address this concern and more? I mentioned it already. We are building the first pilot farm in a wastewater treatment plant. The pilot has been built in the wastewater treatment plant of Castellana Grotte, which is a town in southern Italy, in Puglia, which is a region which has essentially perennial water scarcity. This wastewater treatment plant had a space just after the tertiary treatment component, where we have built our system that consists in a small scale system for piloting and a larger scale system to approach potential industrial production. This is the general overview of what we are doing in the process, in the project, and I like to navigate you through it very quickly. We have the community of Castellana Grotte. The community is producing municipal wastewater that goes in the municipal wastewater treatment plant, where it receives primary, secondary, and tertiary treatment, and then is collected in some collection ponds that are just in proximity of the plant. Normally, the water is used entirely to recharge the water, the groundwater table after this step, so it's dispersed in the groundwater. What we are doing in the project, we are adding a quaternary treatment step that consists of advanced oxidation processes, vacuum UV disinfection, and biofiltering in order to address this concern of the presence of micropollutants in reclaimed water that might be bioaccumulated. And after this step, the water goes to our aquaponics system that is fed with the reclaimed water, but we also have a control line which is fed with natural water. We're using the aquaponics system also to study some other applications that are not directly related to fish and vegetables production, such as extraction of collagen from fish skin, or using the sludge to breed insects that then can be used to produce protein that go back to the fish, or mosses included in the biofilter. So there are some other applications that we are studying. In any case, once the fish and the vegetables are produced in the system, then they go through toxicological testing in order to demonstrate that they are fit for human consumption. We are engaging with several authorities at the local and the European level, because this production system is not covered by regulation at the moment. I will tell you more about it later, but at the moment it is not allowed to use reclaimed water to produce fish and vegetables for human consumption. And then we're going to feed these products to a panel of volunteers in order to, well, get their perception of the fish. So it's going to be a sensory screening, and then also to measure nutrients in blood and demonstrate that whatever we produce with reclaimed water is equivalent to what is produced by traditional means. And then there's a whole component of market study, acceptability, and so on and so forth. This is the general scheme of the project. Now, the quaternary system is a key aspect because we want to get rid of the contaminants of emerging concern and of the micropollutants. I'm going to go over this slide very quickly, but there's an advanced oxidation process, a vacuum UV disinfection process, and a biological rheated filter, already said before, which consists in the quaternary treatment. So we are now growing, going through the first cycle of operation of the system. The fishes have been put into the system in August, but we expect that in 1 year, using 9 cubic meter of water overall, since this is a recirculation system we are not going to use anymore, we can produce 75 kilograms of tilapia and 300 kilograms of iceberg lettuce. This is one of the most solid combination that you have in aquaponics. We are going with this because we know that it works. So we are introducing less variability in an experimental setup that has already a lot of variables that we need to monitor. But it doesn't mean that this is the only combination that might work in reclaimed water. Yeah, so the fishes have been introduced in August, and we are undergoing the first growth cycle in the system. This is a sum up of the wastewater treatment train. We're doing primary, secondary, tertiary, and quaternary. In general term, after secondary treatment, the reclaimed water is fit for discharge, and after tertiary treatment is fit for reuse. After quaternary treatment, we are really not discussing it in any European directive or national directive. But this is what we see. So all in all, after quaternary system, we see a reduction of 60% of the contaminants of emerging concern that we could measure after tertiary system. They go below the detection level. Those contaminants of emerging concern, they are listed in the priority substances directive of the European Union, but they are not yet regulated. I mean, even if the water contains those compounds, it is still considered fit for reuse. This table has just a list of the compounds that we have monitored. This point A is after tertiary treatment, and every red X represents a contaminant that we can detect. And point C is after the quaternary treatment, and we can see that many of these contaminants have gone beyond detection limit. So what does the regulation say? Which is the regulatory framework in which we can move with this? So although our project, but also other experiments from as well, have demonstrated that there's an evidence of safety, or at least equivalency, in farming fish in reclaimed water for human consumption. Nobody in Europe is doing it. And of course, the barriers that exist are of cultural nature and of economic nature. Aquaponics system especially it's hard to make them economically sustainable. But also the regulatory barrier is at the moment preventing utilization of water in aquaculture. And this is because there's no European regulation or directive that explicitly references the minimum water quality standards for aquaculture in the specific. What we have the Water Framework Directive and the Environmental Quality Standards Directive that are used to evaluate the quality of water in natural water bodies. So we're talking about sea, rivers, lakes, and groundwater. And the bottom line of those regulations is that if those natural water bodies, they are of good chemical status and good ecological status according to parameters which are defined in the directive, then the water from these bodies can be used for aquaculture. Also drinking water can be used for aquaculture. But in the case of natural water, it needs to meet these two criteria. It can be used for aquaculture and it can be used for other uses as well. Then there are other directives that go in greater detail about the water quality from some specific uses, like the Drinking Water Directive and the Bathing Water Directive. But you won't find something which is called the Aquaculture Directive. There's a Food Safety Directive that might be used to infer food standards, but you won't find, or at least we haven't been able to find, anything that says water that goes to aquaculture needs to meet this threshold limit. What we have, though, when it comes to water reuse, we have the water reuse regulation that was written in 2000, that was promulgated in 2020, that explains what are the uses for reclaimed water, the possible uses for reclaimed water, but it focuses on irrigation. So the regulation says that reclaimed water can be used for agricultural irrigation, so several types of food crops. And then the member states of the European Union can decide whether they want to expand these uses to industrial water reuse, amenity-related reuses, or environmental purposes. So we're talking about, for example, fountains and management of the green in the cities. What this regulation does, furthermore, is that it defines 4 classes of quality for reclaimed water. The lowest quality is the D quality, which is given to water that underwent secondary treatment and disinfection and has less than 10,000 E. coli per milliliter and meets these other criteria. The highest quality of water, quality A, needs to undergo virtually also tertiary treatment, and then it has a more stringent set of threshold limit. So now, according to the quality class of water, then the water reuse regulation defines also what kind of uses this water can have, but all these uses, they are confined to irrigation. So it's different kind of crops that you can use the water on, sometimes the water cannot be in contact with the edible parts, but everything that is defined here has to do with irrigation. So the water reuse regulation does not explicitly forbid the use of reclaimed water in aquaculture, but it also doesn't explicitly consent to it. What it says is that a wastewater treatment provider need to produce a water reuse risk management plan that is then used as a basis to decide the destination of the reclaimed water.
Sorry, Fabio.
Yeah.
Fabio, sorry for interrupting. Can you please wrap it up because we are at the end of the 30 minutes?
Oh, yeah, sure. Sorry about
Thank
that.
you.
Yeah. However, in particular, what it says is that the reclaimed water shouldn't be discharged close to aquacultures, seeing it as a factor of risk. So it's not doing any favor to anybody who wants to use reclaimed water in aquaculture. The Italian status is really the same. All right, so what we would like to propose with AWARE is that since we are seeing that the quality of water is very high after quaternary treatment, is, for example, to introduce a fifth level of quality of water, a super level, if you want to call it that way, that contemplates the use of quaternary and explicitly permits the use in aquaculture. And that's it. I'd like to thank you, everybody, for listening, and I'm happy to receive your questions.
Thank you so much, Dr. Ugolini, for the great presentation and for explaining a bit more about the AWARE project. We are now moving for the Q&A. So I think now is the opportunity for you to ask Dr. Ugolini anything that you want to clarify a bit more. Let me just add that, Fabio, yeah, you can leave the slides,
Okay.
no problem. Let me just say that it would be possible to turn on the microphone and video for the Q&A, so feel free to mention that when asking the question. So I will start with the first question from my side. Even if this is a recirculation system, do you actually need any external input of the nutrients?
Yes, thank you, Anna. We do. So the aquaponics is not yet a perfect closed loop because we need to introduce some feed for the fishes. Mm-hmm. And this is something that we are trying to address. So on one hand, I mentioned it really briefly, the fishes, they are producing some sludge. Eventually, they have some solid waste. And we can use this solid waste to farm fishes, to farm insects that then are used as feed for the fish in order to minimize the input that we need to introduce externally. But also, in my opinion, it would be very interesting to include into this system also an algae component. It could be on a separate module that is introduced before the aquaponics, and there you can explore the production of algae, for example, to produce single cell protein that also can be used as feed for the fishes, or the algae itself for some herbivorous species of fishes. That would probably put us closer to closing the loop entirely and to have a completely balanced system in the end.
Mm-hmm. Thank you for answering on this question. We just received a question from Hamid. Hi, dear Fabio. Thank you for the great work. I have two curiosity. How do you manage pests or diseases in the systems to prevent them from spreading? Also, is there a strong market demand for both the plants and the fish? I believe for the second one, that's still something that will be evaluated throughout the projects to see what is the public perception on this, right?
Yes, that's correct. So regarding the possibility of pests and diseases in the system, so at the moment we are not observing anything amiss. We don't have any particular prevention measure. The system is a closed one. It's an experimental closed system, so it has very little exchange with the extern. What we have seen is that although it's not a pest, a fish pest problem, we've seen that we can introduce contamination, for example, with the soil that remains attached to the roots of the plants. So since we've seen that in the beginning, now we are implementing a stricter cleaning protocol when we are introducing an external cultivar to the system. But we don't have any other measure to prevent possible spreading of diseases. We have this closed system that prevents the spreading of diseases from the system to the environment. That's also something that we put there. Regarding the acceptability, unanticipated it, we expect that there will be some resistance to fish which is farmed with reclaimed water. I mean, there's already resistance with, at least in Italy, with fish which is farmed in aquaculture. People would just go for white catches because it's associated to a higher quality, better taste. It's a cultural thing. And we expect there's going to be resistance for reclaimed aquaculture. What we want to try to do is not really immediately go to the mass consumer market. We want to leverage a little bit more the environmental sensitivity of potential consumers. So the idea is whether to investigate whether there's going to be groups in the population that are more sensible about environmental matters. And those would be the one who are more in favor of purchasing food that originates from this kind of system. Yeah, this is something that we haven't yet looked at.
Thank you. The next question is from Fahad Assiri. Hi, Fabio. Thank you for interesting presentation. Have you conducted any cost or economic analysis to assess the feasibility of producing fish using aquaponics with reclaimed water and compared it to the conventional water, especially after applying quaternary treatment, which incurs additional costs?
Yeah, that's a very good question. So we don't have the full LCA yet. This is planned for this year. We had some preliminary estimates. So the quaternary system, this has a capital investment of 100,000 euro. Like this is just capital investment. Then the operational investment comes from energy that can be offset if you use renewable reagents because it uses ozone. And then, well, you need manpower. So now, if you consider that this is part of the wastewater treatment system, and the wastewater treatment system is normally a public service, this is not going to really to affect the economics of the aquaponics. It's more the economics of the wastewater treatment, which is, I mean, it's a good thing and a bad thing depending on how you look at it. This is normally paid through the taxes, but then you get better quality water back in the environment. The aquaponics itself, I would say that the economic aspect, it's also a very large barrier in addition to the regulatory. If we run our estimate just with the volumes that we can produce at the market price of tilapia and lettuce, it's very hard to raise even 20,000 euro per year. So the system by itself cannot work, at least the way it's conceived, as a classical aquaculture that sells fishes and vegetables to the consumer. So we're thinking about different business models to keep it alive. For example, I could go ahead talking a lot about this. We can have a side panel, but so one idea that we want to explore with the consumers is the idea of adopting a tank. So you're not really buying the system, you are buying the idea that you like to have a circularity in the production. So you don't really care about how much fish you get. You are adopting a tank, and then you get the production at the end of the year, so that the farmer that would manage the aquaculture system has a form of steady income, or at least it can rely on that particular income, and then the consumer gets the production, but it's promoting a circular system. So it works with the olive trees in the region. We need to see whether this is something that could be accepted by the population. Otherwise, the other option is to really scale up the system until it becomes economically viable, because you need to have much larger size. You need to focus more on the plant production. A lot of aquaponics, they make money by selling, for example, aromatic herbs, which are normally, which have a better revenue per dry mass. That would be something else. But then the systems need to be larger than this one.
Thank you. I will start with another question. Hi, Fabio. Are there incentives or subsidies available for aquaculture operations to adopt reclaimed water as a more sustainable resource?
Well, there are not, I'm not aware of any targeted incentive for that, but there are some instruments the European level, like the aquaculture support mechanism, that evaluates different initiatives in aquaculture. So it might be something that that goes in that direction. At the national level, at least in Italy, there are subsidies for some form of agricultural production. I don't think there is any subsidy for aquaculture. So I would need to do some research in order to be able to answer that question more precisely, though.
No problem. We have Eleni Mente here. Hi, Eleni. She said, hi, Fabio, congratulations. And thank you for the presentation. How can someone match the co-culture of specific fish species and plants? I mean, where can you get advice on this?
Sorry, can you, how can one match the core?
The co-culture of specific fish species and plants.
Ah, okay. Well, so there's, I said, there's no centralized resource for aquaponic farmers, but the aquaponic communities, those are both in the scientific world and in the productive world and in the holistic world, they're very active. So I would imagine that by consulting with any aquaponic communities, one could get useful information for co-culturing of species, but I'm not aware of any really centralized database that might have the kind of information. It's done a lot of university level, and there are some productive realities that have already consolidated combination. So I would refer to those. In the project, we are relying on some aquaponics experts from the aquaponic world and from the industrial world. There's the Alfred Wegener Institute in Germany, the University of Thessaloniki in Greece. We have an aquaponic farm on board from Spain, so we are using their experience.
Thank you, Fabio. The next question is again from Michael. Can be considered by using the income from selling fish and lettuce more as a system to reduce the cost for a method to have more effective wastewater treatment than producing aquaculture species?
That might work. Okay, it's also another discussion. So you might in this project, the aquaponics system is not really helping treating the water. But you could imagine that as they did in Munich at the beginning of the 1900s, you might have the system earlier in the wastewater treatment train in order to reduce the organic load in the wastewater. So you get away the carbon, the phosphorus, and the nitrogen, and then you give it to the fishes, and that would be a way to produce fish and clean the water at the same time. So this could be possible, but we have to consider that, first of all, there's already other methods. If your objective is cleaning the water, there are more effective methods. So this would make sense only if you have a considerable advantage by farming fishes and vegetables. Personally, I don't know how feasible is that to have this as part of the wastewater treatment, because if you ask me, then I would go, for example, to other systems like phytodepuration. Maybe it would be more effective. But it's certainly an idea which is worthwhile exploring. And in that case, yeah, you would have revenue from fishes, but then you are actually financing the wastewater treatment train.
Thank you, Fabio. I think we still have time for one more question. And this is from Ottilia. Hi, Fabio. Great presentation. Thank you very much. I have a question about the regulation. Are there already discussions in the EU to create regulation? Because how can you proceed to complete the project without implementing the regulations?
So the project is experimental. So we are already authorized to produce fishes and to use it as not as food, as biological material on a panel of volunteers. So, but then of course, if you want to make it productive, we need to have what I think would work best would be an amendment to the water reuse regulation. And for that, we have already talked to the JRC, so the Joint Research Center group that works on wastewater, and it was responsible for drafting the previous regulation. And they want to see evidence before even initiating this kind of conversation. It's not going to be a fast process, but at least they are aware that this aquaculture situation is really in a gray zone at the moment, and there's no real technical barrier for not having it included in the wastewater reuses.
Thank you, Fabio. So I only have one more question, and this is from my side.
Yeah.
What would be, in your opinion, the next development step for this for the project?
Oh yeah, I would love to see two things, and maybe the people in the audience can help me with that. So once I already mentioned, I think it would be really, really cool to rethink the system so that we have an algae production module before that. So we use the nutrients in wastewater to make algae, and that could be also phytoremediation. And then we use the algae as feed for the fishes, and we close the loop. And then on the other end of the loop, you have the sludge, which is generated by the fish, right? So now what we're doing, we make insect meal from the sludge, but also one possible way to do, and they do it in sea aquaculture, in like when you make shellfish and everything, is to have a multi-trophic system where you have a benthic species which stays on the bottom of the fish tank and eats the sludge which is generated by the fishes. So in a saltwater system, you will have sea cucumber to do that. In a freshwater system, we don't have it. So that would be the other thing, to find a multi-trophic combination that actually removes also the sludge component. And then you have a perfectly closed loop, well, maybe not perfectly, but you have a better closed loop that could be really interesting to apply in situation where you need to have extreme conservation of resources. Anything I'm thinking aquaponics on Mars or something like that.
So we received one more question. I don't know if we have time or not. We are already extended the time, but let me read it before I finish. And this is the last question for today, I promise. In terms of panel of volunteer, what is their protection mechanism in case of any health issues detected?
So the volunteer panel and the sensory test is carried out by a partner that does that for a job. So the University of Ulster. So it's in a hospital, and there's going to be a medical assistant. There's an ethics panel that needs to approve everything. So I would say that the safety measure that are going to be in place are those that are normally used in all sensory test evaluations. And of course, before we can even feed the fishes to the panel of volunteers, we need to have the toxicological exam of the fish ready, which needs to be approved by the ethics committee. So the procedure is quite strict. And in case of emergency, there is going to be a medical professional, of course, but we don't expect any acute or even not acute effect.
Thank you, Fabio. Thank you for everyone that asked the question and were part of this quite fruitful discussion. There was one question about where can you find the slides? So if you're the member of the European Aquaculture Society, on our website, after probably in a week, you will find the video recording of this webinar and also the slides from today's presentation. We hope you enjoyed this presentation into valuable insights into the potential of reclaimed water aquaculture system. Thank you once again, Dr. Ugolini, for your time and expertise, and thank you so much for the engagement.
Thank you, Anna. Thanks everybody who attended.